Okay, Mr. Hunt here with coordinate geometry. So first of all, at the top of the page, this is page 8 currently, there's a list of formulas you got to know but that we're going to use a lot in coordinate geometry. And coordinate geometry is geometry, triangles, lines, planes, quadrilaterals, just equations of a line, anything that's on a coordinate grid. So I'll pull up a coordinate grid here in a second, but for the first one, we're not going to need it. So there's a list of all these formulas. Pythagorean theorem is given. I think we know that one. Midpoint formula. Yep, got to know that one. It's an average. Slope, rise over run, or it's the y2 minus y1 over x2 minus x1. Yep, got to know. Area of a triangle, parallelogram, and trapezoid. Those formulas are actually given on the formula sheet, but we got to know how to use them. And then one of the equations of a line, slope, intercept, point, slope. For number one, I'll do one form. For number two, I'll do the other. And then we got to know parallel lines have the same slope and perpendicular, opposite, reciprocal. So a lot there is review. But what's going to be new, so we're going to review some things, certainly, but then we're just going to extend a little bit. The air certainly has some questions on there that like find perimeter, find area of a figure on a coordinate grid. So we'll extend to that. We'll do classify quadrilateral as well. So let's do number one here. This is, again, some of these are definitely going to be a lot of review. Equation of a line that contains the point 7, negative 2, parallel to the line 2x minus 5y equals 8. So first thing I need to do is get the slope, and it's parallel to this line. So I need to solve for y here. So I'm going to subtract 2x from both sides and divide by negative 5. By the way, as I'm doing this, of course, just always, if I go too fast, you have the beauty of technology. You can just pause it. All right, so some of this work I might work out fairly quickly. Slope there is 2/5. A parallel line will also have the same slope. If it's a perpendicular, we would have used negative 5/2. So then let's do point slope on this one. So x1, y1, point slope is y minus y1, m, x minus x1. So this will be y minus a negative 2 becomes plus 2. Slope of, what did I say, 2/5. X minus 7. Okay, distribute the 2/5. So we got y plus 2 equals 2/5 x minus, this will be 14/5. Calculator would say 2.8. And then subtract 2, so here's our equation, 2/5 x. Let's see, minus 2, that'd be minus 10 over 5. And we just add the numerators, so negative 24/5. Or, I think, 4.8. Okay. Sorry, cut out there a little bit. There we go. Next one I'm going to do is a perpendicular bisector. This is definitely a review, but it's one we haven't done in a while, need to make sure to do. So you have 2 points, and I'm not going to pull up the grid for this one yet, but basically the concept is this. Negative 3, 5 is right here, 1, 7 is up there. You want a perpendicular bisector, so you want a line, switch colors here. So you want a line, it's going to go through, it's going to bisect, and it's going to make a right angle. So first, let's get the midpoint. It's got to go through the midpoint. Bisect, cut in half. It's got to go through the midpoint. So midpoint, x1 plus x2 over 2 divided by 2. y1 plus y2 over 2. Average of the x's, average of the y's. Negative 3 plus 1 over 2 and 5 plus 7 over 2. So we get negative 2 over 2, negative 1, 12 over 2, 6. And that'll be, I'm going to use slope intercept for this next one. So that'll be our x and our y. Second thing we need, excuse me, midpoint. Second thing we need is perpendicular. So we find the slope of this line and make it perpendicular. So I can do rise over run after plotting it, or I can just do slope formula, y2, so this is x1, y1. y2 minus y1 over x2 minus x1 becomes plus 3. So it's 2 over 4, which is 1/2. That's the slope of the line I circled here. Perpendicular slope, we want -2. Really -2 over 1. And then, so flip it and change the sign. Okay, so then we use this slope and this point, and then I repeat the same as number 1. Biggest thing I've seen, if you get this far, so midpoint, don't forget about that, because probably one of the biggest problems is students use one of these points. You got to do a midpoint. So you have to find the slope, change it to perpendicular, and then use this midpoint one. I'm going to go to new page, 6, -2. Okay, so I'll do slope intercept this time. So that just says plug all these in. My slope is -2, that's the M. X is -1, B is B, and Y is 6. And the goal here, if you do this one, you got to solve for B. So I have 2, I subtract 2, I got 4. So the final equation, I put my slope from up here, -2x plus 4. All right, it's an equation of a line. That'll be perpendicular and it will bisect. Okay, next thing I'm going to do is, I'm now on page 9, perimeter and area and the coordinate plane. Perimeter, distance around. It's really pretty simple. They've given several of these on the air test, and what they do is they just give a shape. These are released questions. They give you a shape. I think, remember, one is a quadrilateral, like a trapezoid. You got to find the length of all 4 sides and add them up. Area, amount of space inside. We have 3 formulas. You use the one, you find the base, height, or a trapezoid, 2 bases. Use the formula, plug it in. So let's do the first one. I will pull up a grid here. What's this one? Oh, nice. We'll pull up a grid and graph these 3 points. Might be kind of tough for me to put it exactly on here. Yeah. So that's -4, 4. 6, 4. I'm skipping to the other one. 3, 4, 5, 6. So I think I got that. It's just hard on this. It's kind of small. 6, 4, and then 3, -8. So I think I got that. 3, -8. Okay, find the following. Classify the triangle. Well, can't just assume it's something by looking at it, so we need to find the length of the sides. This one we can just count. So you might want to pause it. You might want to pause it and see if you can do this one. All of these are just getting you ready to do the practice on your own. Count that 6 and 4, 10. To find the other 2 lengths, I have to do Pythagorean theorem. So I make a right triangle here. Looks like this is going to be 3 and this is 12. And I make a right triangle here, 7 and 12. So I do 3 squared plus 7 squared equals c squared. And we do 3 squared, oh, I had that wrong, plus 12 squared, sorry. And then we do 7 squared plus 12 squared equals c squared. Kind of have these backwards. Again, do the work here, square them, then sum them. Radical 1, 53, radical 1, 93 is what I got. So part A, classify it. Well, we had 10, and then these 2, none of those are equal to 10. They're not equal to each other, so they're all different. It's a scaling. 2 the same, you would have said isosceles. 3 the same, equilateral. Perimeter. So you just got to add them all up. Add these 3. Just put them in your calculator. I'll try and say, oh, I did say round to the nearest hundredth. There we go. So you put it in your calculator. I got 36.26. And see, find the area. Now, it's 1/2 base times height. I'll work this way. Okay, so you just got to choose a good base. If you choose this as the base, well, how are you going to find the height? It'd be this, and then that's creating more problems. You can, but it'd take a while. So choose a good base. How about this one? Because if I choose this base, then my height, I can just count. It's vertical. So if I choose the base as 10, I can just count this, and the height is 12. I do not distribute the 1/2. I see that sometimes. It's just you multiply all 3 of these. So you put them in, let's see, 60? Yeah, 60. There were no units, so I'm just going to put u squared as units squared. Oh, and perimeter here, just units. Okay, mostly working with triangles here. So the next one is a triangle. Determine if it's a right isosceles triangle. Okay. I'll pull up the grid. Might be better this way. So I'm just going to approximate here, but they got 1, 3. They got this point, 5, 6. I'm just putting, so we have the diagram. Okay. So first of all, let's do, is it an isosceles triangle? Okay. Let's see. Well, what I'm going to do is I'm going to find the lengths, and I need to do Pythagorean theorem. I need to do Pythagorean theorem. I get to this. There we go. So what happens here, again, my drawing's way off here, but try this out. Do it on your own. Try these 3. Pause the video. I'm going to keep going here, but this was 3 and this was 4. Could I do Pythagorean theorem? Sure. But don't we also know 3, 4, 5, Pythagorean triple? What's interesting, you get the same thing here, 4 and 3. So 3, 4, 5, this is 5. So it's at least isosceles. And then if you do this final side, it's what, 1 and 7. It's not, well, we should try it just to verify. It's not going to be, it's going to be radical 50, which is not equal to 5. So it is 2 sides congruent, the third is not. So yes, it is isosceles. So I'll put that here, yes. Next, is it a right triangle? So to be a right triangle, it needs to have one right angle. And we can probably guess, again, my drawing's a little off, but it's going to be this one, if it's the right angle. Okay, so how do we check if it's a right angle? We need to see perpendicular lines that intersect. If these lines intersect to make a right angle, that's called perpendicular. Okay, so perpendicular makes a right angle. Well, we know the slopes for perpendicular are opposite reciprocals. All right, so we're going to look at the slopes. So I already have them, actually. It was rise over run. This one was 3/4. This one down here, negative rise, -4 because it's down, -4 and over 3. So looking at those, are they perpendicular? Yeah, opposite reciprocals. So what does that mean? It means they're perpendicular. It means this is a right angle. So yes, it's a right triangle. Okay, I'm going to cut it off here. I'm going to do part 2 on a separate video. So this is part 1 so far with coordinate geometry.